7.4, repeating decimals. Writing repeating decimal as a fraction. We're going to let a variable x equal the repeating decimal d. Step 1. Write the equation x equals d. Step 2. Multiply each side of the equation by 10 to the nth power to form a new equation where n is the number of repeating digits. All right, step 3, subtract the original equation. From the new equation. Next step, step 4, solve for x. So I'm going to be referring back to this. I just won't be showing it, so you'll have to look at yours. So example 1, writing a repeating decimal as a fraction with where only one digit repeats. So we're going to write 4/10 repeating as a fraction in simplest form. So step 1, write the equation x equals d. So x equals our decimal, which is 4/10 repeating. Step 2, multiply each side of the equation by 10 to the nth power to form a new equation where n is the number of repeating digits. How many repeating digits do we have? We have 1. That's the number 4. So that means I'm going to multiply by 10 to the first power x. Multiply by 10 to the first power. So we want to do that on both sides. 10 to the first power is just 10, so that leaves us with 10x equals 10 times 4/10 repeating is 4 and 4/10 repeating. Step number 3, subtract the original equation from the new equation. My original is x and 4/10 repeating. So I'm left with 9x equals 4. I'm going to divide both sides by 9. My answer is x equals 4/9. To check to see if you did it correctly, you can plug 4/9 into your calculator and you should have 4/10 repeating. On your own. Try the next two and then check. Write the decimal as a fraction or a mixed number. -5/10 repeating. So x equals -5/10 repeating. I only have one digit repeating, so that's 10 to the first, which is 10x. Which leaves me with -5 and 5/10 repeating. Subtract the original equation from both sides. So that's actually adding the opposite here. So we're left with 9x equals -5. Divide both sides by 9. You'll get that x equals -5/9. Letter C. X equals 5 and 8/10 repeating. You have one digit that's repeating, so you multiply it by 10 to the first, which is 10. Multiply this by 10, that's 58 and 8/10 repeating. Subtract our original from our new. That gives us 9 equals 53. Divide both sides by 9. You get x equals 53/9, which that is actually 5 and 8/9. If you saw from the beginning that you could just take the 5 out and just find the 8/10 repeating as a fraction, you could also do that. So we're going to compare the repeating decimals and their equivalent fractions in the last 3 problems. So we had 4/10 repeating, that was 4/9. We had -5/10 repeating, that was -5/9. We had 5 and 8/10 repeating, that was 5 and 8/9. Do you see a pattern? Well, they're all being divided by 9. How can you write a repeating decimal as a fraction when only the tenths, emphasis on the tenths digit, repeats? You would write the digit that represents, oh, sorry, that repeats, darn it, sorry, that repeats in the numerator and use 9 in the denominator. Again, only works when the tenths digit is repeating. All right, let's continue learning. Example 2, writing a repeating decimal as a fraction with 1 digit repeating. So we're gonna write negative 23/100 repeating as a fraction in simplest form. So x equals negative 23/100 with the 3 repeating. You only have 1 digit that repeats, so you're still only multiplying it by 10, which will give you negative 2 and 33/100 repeating. The reason why I extended this out to say 33/100, I want these to be able to match up. So I'm going to subtract the original from the new. So this actually becomes adding over there. You have 9x equals negative 2 and 1/10. Divide both sides by 9. X equals negative 2 and 1/10 divided by 9. You can't have a decimal as part of your fraction, so I'm actually going to multiply this whole fraction by 10 to get this to just be 21 divided by 90. That means I don't have a decimal anymore, and then I can simplify. Divide by 3. You have 7/30. Ooh, I forgot to continue with my negative. So negative 7/30 is my answer. All right, moving on. Example 3, writing a repeating decimal as a fraction with 2 repeating digits, or 2 digit repeats. So we're going to write 1/2500 repeating as a fraction in simplest form. Our x is 1 and 2500 repeating. Well, we're going to multiply both sides by 10 squared. Ten squared equals 100. So every time, however many zeros you have, that's what your exponent is. If this would be to the 4th power, you would have 4 zeros. So 100x equals 125 and 2500 repeating. I'm going to subtract my original equation. 99x equals 124. Divide both sides by 99. I get x equals 1 and 25/99. All right, try the next two on your own. Write the decimal as a fraction or mixed number. So x equals 2700 repeating. This is going to be 100x equals 27 and 2700 repeating. Subtract the original decimal. 99x equals 27. Divide both sides by 99. X equals 27/99. I can simplify by dividing by 3. And I am left with 3/11. Oh, I'm sorry, I can divide by 9. Not by 3. You could have divided by 3 and then divided by 3 again. That would have been okay. All right, letter H. This time I'm actually going to pull out my -4. So I put that down here. And it's going to be over something. So I'm going to take that out. And I'm going to say that x equals 50/100 repeating. So that's 100x equals 50 and 50/100 repeating. I'm going to subtract the original equation. You get 99x equals 50. Divide both sides by 99. You get x equals 50 99ths, so that's -4 and 50 99ths. So we're going to compare the repeating decimals and their equivalent fractions in the last three problems. Do you see a pattern? Yeah, they all are being divided by 99, well, except for this one, but that's because we simplified. How could you write a repeating decimal as a fraction when only the tenths digit and hundredths digit repeat? So we're going to write the digits that repeat in the numerator and use 99 in the denominator. You're going to